Hello everyone, it's Alex back with the videos. Now in this video, I'm going to explain to you how to solve mathematical equations where you have pronumerals on both sides of the equation. So what I'm going to do in this video is go through some simple examples, and like my previous videos, I'll go through some worded problems as well. Okay, so let's get started. So this is an example of an equation where there are pronumerals on both sides. As you can see, there's a 7x on the left hand side, which has an x as a pronumeral, and there's a 3x on the right hand side. So this is an equation with pronumerals on both sides, and don't be afraid of this because it's actually not too challenging. So I'm just going to guide you through it, and hopefully you'll be able to understand. Now, the aim of this is to try and make sure that there's only one pronumeral on one of the sides. So at the moment, there's one on each side. We want to break this down into something with a pronumeral on one of the sides. So there's two methods that we can do this. To get rid of the pronumeral on the left hand side, what we can do is take away 7x. Now remember, if we do this to the left hand side, we also have to do it to the right hand side because that's fair, right? So this is one option. Now the other option would be to what? To take away 3x from both sides, right? Because it's a 3x on the right hand side. So we can also do this. Okay? So it does not really matter which option you take. You can either take away 7x from both sides or take away 3x from both sides. But I personally prefer to take away 3x, and the main reason is because if we take away 3x from both sides, you have 7x take away 3x, which is a positive number. However, if you take away 7x from both sides, then you end up with 3x take away 7x, which gives you something negative. And we want to try and avoid negative numbers if possible. So I'm just going to go and take away 3x from both sides. So then we do 7x take away 3x, which is 4x, plus 7, right? And that's equal to what? 19. Now it's just going to be 19 because 19 plus 3x, take away 3x will give you 19. And this equation is a much more simpler version of this first equation, right? So we've progressed one step ahead. Alright, and in the next step, we try to make sure that there's only a number on one of the side of the equation. So at the moment, you have a number on the left hand side and on the right hand side. We want to make sure that there's a number only on the right hand side. Okay, so we can do this by taking away 7 from both sides. Okay, so once we do this, we are left with 4x is equal to 12. And in the next step, we want to make x by itself. So how can we do that? We can divide both sides by 4 because we know that 4x divided by 4 is x. So then we divide 4 to both sides. We get x is equal to 3. And this is our solution to this equation. So just to recap, when it comes to having equations where there's variables on both sides, what you want to do is you want to break this equation into one where there's a variable only on one of the sides. So as you can see, in the second equation, there's a variable only on one side of the equation. It's not on both sides anymore, right? Once you've done this step, then you have to make sure that there's only a number on one side of the equation. So you can do this by taking away 7 from both sides. You get 4x is equal to 12. And then the last step is to convert the 4x into x, which is done by dividing it by 4. Okay. So hopefully this is quite straightforward. I'll go through one more, slightly more complicated example, or like this one here. So this one has a fraction, and like I said earlier, a lot of students simply do not like fractions. But don't be afraid. The concept is still the same. So in here we have two options. We can either take away 2m from both sides, or we can take away half m from both sides. Now, like I said before, I will take away half m because that will lead to a positive number. Because 2m take away half m gives you something positive, whereas half m take away 2m is something negative, right? So I'm just gonna go and take away half m from both sides. Now you have to be careful here because now we're taking away a fraction from a whole number. So what you can do is think of it like this: 2m take away half m. So if I have 2 apples, take away half an apple, how many apples do I have left? I should have 1.5 apples, right? But because I do not like writing mixed fractions, I'm just going to write this as a fraction like this, because we know that 1.5 is equal to 3 on 2, right? So 2 take away a half is equal to 3 on 2. 3 on 2m. Take away 5 is equal to, now we know that half m take away half m is going to be 0. 0 take away 2 gives you minus 2. Okay. So just bear in mind that going from this step to this step is the most challenging step, because you have to take away half m from both sides. 2m take away half m gives you 3 on 2m. Okay. So just make sure you know that. Now the next step, we can add 5 to both sides, as this step should be quite straightforward, at least I hope. So then we know that the minus 5 will be gone, because minus 5 plus 5 gives you 0. So 3 on 2m is equal to minus 2 plus 5 gives you 3. Okay. Now, to move on to the next step, there's actually a few ways that you can do this. Now, there's a slow way and there's a quick way. So I'll go to the slow way first. Okay. So the slow way is to do it like this. So you have a 3 on 2m. So this is a fraction. To get rid of the fraction, we have to multiply by the denominator. In this case, the denominator is 2. So we can multiply both sides by 2. Right? And for those of you that don't know, 3 on 2m is actually equal to 3m on 2. Okay. So make sure that you know this. They're exactly the same. Alright, so I multiply 2 to both sides. So then what I should be left with is the 2 should just vanish. So then I should get 3m is equal to what? 6, right? And then m is equal to, sorry, I didn't show my working out. I'll divide 3 to both sides. So then I get m is equal to 2. Okay, so that's one way to do it. So that's method 1. Okay, now to do method 2, it's a bit more abstract, but I think it's the faster way to do it, and maybe you will appreciate this method like I do. Okay, I'm just gonna rub this out first because I don't want that to get in the way. Now, say if we were given an equation, say 4x is equal to 8, right? Now what we can do is, to solve this, we divide both sides by 4, right? That's how we would normally do this, and we get what? X is equal to 2. Now we can apply the same concept to this question, okay? So how do you do it? Well, you have 3 on 2m is equal to 3. So I can divide both sides by 3 on 2, right? Right? Because then if we divide 3 on 2m by 3 on 2, we get m. So we can divide both sides by 3 on 2. So then what we should be left with is, this divided by 3 on 2 gives you m. And then the right hand side, now this gets a little bit confusing, but what you essentially have is 3 divided by 3 on 2. Okay. Now, if you're not sure how to do this, you can just simply type this into your calculator. Okay. And your answer should be 2. But if you want to know how to do these kind of fractions without a calculator, it's also very good to know. So what you can do is this, and this is not something teachers will explain to you in school, because you will not usually get into these kind of awkward situations. But what you can do is this: because we have a fraction inside a fraction, we need to get rid of the bottom fraction first, right? Because it does not look pretty to have a fraction inside a fraction. So to get rid of the bottom fraction, remember the rule, you multiply by the denominator. So you have to multiply this by 2. Now with a fraction, if I multiply the denominator by 2, we also have to multiply the numerator by 2 as well, to ensure that they're the same fraction, right? Do you remember that a half is also equal to 2 over 4? Because we know that if we multiply the top and bottom by 2, we get 2 over 4, right? So then we multiply the bottom by 2, we have to multiply the top by 2 as well. So then what we should be left with is 6 over, now the denominator multiplied by 2 will give you 3. And this equals to 2. So as you can see that we got the same answer using the second method. But feel free to use any method you like. I personally like the second one more, but it can be a bit difficult to get used to in the beginning. Okay. Alright, so now I'm going to go through my next example. The next example is finding the value of x and y in the rectangle below. So as you can see, I've drawn this beautiful rectangle and I've labeled some of the sides with variables. And it asks you to find the values of x and y. So first of all, to do these kind of problem solving related questions, you have to know what a rectangle is, first of all. I mean, other than the fact that it looks like this, we know that a rectangle has opposite sides being equal, right? So if opposite sides are equal, then we can just say that 3x plus 1 is equal to 5x minus 11. And we can also say that 2y plus 3 is equal to 4y minus 17, right? Now once you've established these equations, now we can just solve them. And that will get you the answer of x and y. So like I said earlier, the hardest part of these kind of questions is writing the first step. And that's usually where students struggle the most in. So to do this, I'm just going to take away both sides by 3x because we know that 5x take away 3x will give you a positive number. So you should get, this should give you 1 because 3x take away 3x equals 0 is equal to 2x minus 11. We can add 11 to both sides so that you have a number on the left and a variable on the right. So you should get 12 is equal to 2x and 6 and divide both sides by 2. You get 6 is equal to x. In other words, x is equal to 6 because that's the way I want you to write your answers. Now for this, you just do the same thing. So I'm just going to do it quickly here. You take away 2y from both sides. Right? Because we want to make sure that the 2y is gone. So we're left with 3 here is equal to 2y minus 17. Next step, we can add 17 to both sides. So that we're left with a variable on the right hand side and a number on the left hand side after we do this. So that will give us what, 20 is equal to 2y. Divide both sides by 2 to make sure that 2y becomes y. So then we get 10 is equal to, oops, I made a mistake here. I meant to divide both sides by 2, not divide both sides by y. 10 is equal to y, and y is equal to 10. Okay. So as you can see, that's how you do a question like this, and hopefully you can kind of see the importance of learning how to solve equations with variables on both sides, because it helps you do questions like these. Alright, so now I'm just going to go through one final example, and hopefully after this you will have understood everything about solving equations with variables on both sides. At least, I hope so. Now this question says find the value of the pronumerals. So as you can see, there's 3 pronumerals here. There's the x, there's the y, and there's the z. Now how do we do this? So with these kind of questions, you need to know a little bit about your shapes, your geometric properties, okay? So as you can see, this is a triangle, but in particular, what kind of triangle is this? If we see that there are 3 lines on this triangle, that means we know that these 3 sides are going to be the same, okay? Because each side has 1 line on it, so it means all the sides are the same. If all sides are the same, then we can say that this is an equilateral triangle. Okay, this is an equilateral triangle. So what do we know about equilateral triangles? Well, we know that equilateral triangles, all the angles have to be equal because all the sides are equal, right? If all the sides are equal, then all the angles are equal. And we know that equilateral triangle, the angles, they have to add up to 180 degrees, right? Actually, this is a rule for all triangles, not just equilateral triangles. So if all angles add up to 180 degrees and each angle is the same, then we can say that each angle should be 60 degrees, right? Because 60 plus 60 plus 60 gives you 180 degrees. So each angle is 60 degrees. So once we know this, then we can apply this number to these equations. So we know that 3z is equal to 60 degrees because this is one of the angles in the equilateral triangle. We know that 2y is also equal to 60. And we know that x is equal to 60. Right. Well, this one is already solved because it's already x is equal to something. So we just have to solve these two equations. So to solve these, it's pretty simple. You just have to divide both sides by 3. So you have z is equal to 20. To solve this, you divide both sides by 2. So then you have what? Y is equal to 30. So then once you've done this, then you've basically written the answer. So you know that z is equal to 20, y is equal to 30, and x is equal to 60. Now, some of you might be thinking why I didn't write the degrees for the 20 and the 30 and the 60. And the reason is because this question already has the degrees written for you. So say if we wrote x is equal to 60 degrees, that means if we actually substitute the x into here, we will end up with 60 degrees, right? And that would not be good. So this is just a small thing. It's not too important, but just remember, in these questions where the degrees is already given to you, you do not need to write the degrees in your answer. You can just write the number, okay? Alright, so this is all for today. So I hope you've learned something new, and I'll see you next time.